welcome, and thanks for turning up. And I know this is the last talk between you and beer, so we'll try and stay on time. So, let's see, where are we? Ooh. Are we not? Whoa, there we go. Sometimes when you plug it in, it seems like the network gets hitchy. This is off of Google Slides, so optimistically. I'm Julian Hjortshoj. I work for Dell EMC out of the CTO's office, but I'm also the product manager for the Cloud Foundry Volume Services team.
Hi, I'm Daniella Corricelli, a product manager with Pivotal, and my team's focused on the .NET developer experience.
So, yeah, no, I don't need that. It'll cause strange echoes. So, whoa, I've gone too far. There we go. There we go. Sorry. So every good story you've seen, like Star Wars and the Odyssey and all of those, all sort of follow the same dramatic arc that's referred to as the hero's journey, in which your hero starts off in a nice, cozy, home-like place and then wanders out into the wilderness and hits obstacles, is ultimately successful in surmounting those obstacles, and then comes back home again at the end. So we're going to tell you a similar story about starting in the nice, cozy world of Linux development and then wandering into the nasty hinterlands of Windows development, running into problems, and ultimately solving those problems and bringing home the solution. So with that, let's get started. I've gone too far again. Spacebar is not my friend. So home, for at least as far as we were concerned on the Volume Services team, looks like the Linux workflow. And that for us is creating a service which represents some remote mount of a file system and then binding that service to your app. And that in turn causes that mount to become available to your container. And so what that kind of looks like, let's see if we can make this go. Oh, this is an interesting experience that I had not anticipated when I canned this demo. So what does that look like? That looks like CF push. This is a little demo app. It's like a little Hello World app that when you hit the right endpoint, writes a little message into a file, reads it back out again, and then puts it on the screen. So for us, we're pushing this app, and now it's doing all the build packy things, and it's making the droplet run, and off we go. So now we've got it running, and we're going to create a service that maps to an SMB mount. Let's see, we give it the UNC name, and then we're going to bind that service to our app. And we're going to restart it. And on restart, it'll go do the mounty thing. And now, once this thing starts, now we can curl the right endpoint on that new app I just pushed. And it comes back with a nice hello persistent world message. So under the covers, what's that doing? That's on the app binding, that's inserting a little volume mount message into what we call the desired LRP of the app. And then once that app gets placed on a Diego cell, we send that binding to a Docker volume plugin that creates a mount on the Diego cell of that remote thing, using just a kernel mount. And then from there, when we start the application up, we add that mount to the list of things that ought to get bind mounted into the application container. And hey, presto, your application has access to the mount, and off you go. So theoretically, we're thinking to ourselves, like, yeah, Windows will just do the same thing we did in Linux, right? It'll be no problem. We'll just mount it onto the Windows cell, and we'll somehow stuff it into the container when we start the Windows container, right? As they say, what could possibly go wrong? It'll be great. Right. Yeah. This was a total bust for a couple reasons. On the first attempt, NetUse in Windows or new SMB mapping really only works for the user context that you do it in. So we got the thing mounted, but then you couldn't get it into the application container. Like, it wasn't available to that other user context. So that was not working. And then Windows, to try to make that problem better, came up with this new SMB global mapping idea, which would theoretically make mounts on Windows sort of like Linux. But that thing was like too global in the sense that if you mounted a remote share with a set of options, then that was the only thing you could do with that remote share. And the second one, maybe with a different user or some other mount option, would just fail because that remote share is already mounted. And then even if we got that worked around, you needed to associate a drive letter, meaning like you could only have 20 odd mounts per Diego cell. So it was just awkward. And we thought about like, oh, well, we could kind of codify all these limitations into a service broker that would enforce only one app gets to use a remote mount. But that would have been kind of rubbish. So we thought, yeah, this is really a square peg in a round hole. And it didn't really make sense to keep going. So we kind of gave up on the volume services team side. Fortunately, the .NET team had this use case on their radar. I'll turn over to Daniella to talk about that.
Yeah, let's talk about the Windows side. First, I'm going to take a step back. If you're a .NET developer, then you're probably familiar with the concept of domain joining. So this, outside of PCF, or outside of Cloud Foundry, you would connect to your enterprise SMB share, and your admins would set the configurations for you. In Cloud Foundry, we do not have domain joining. So for that reason, and some of the reasons that Julian outlined, we thought we might have been out of luck connecting to SMB from within Cloud Foundry. Fortunately, in Windows Server 1803, Microsoft did release a way to enable SMB shares, allowing .NET to be used from container processes. So as Julian mentioned, under the hood on the Linux side, when you're using CF create service and bind service commands, we're connecting from the network volume to your app in Cloud Foundry. So it's the cell that initiates this from the service broker, reaches out to the network share, and makes the mount from the volume service broker, which injects it into the container. On the Windows side, we set our storage credentials at the container level. Using the net use command, we can call it from a container processes and connect to the network volume. So why didn't we use the same binding workflow in Linux? Historically, Windows has had more of an opinion about virtual file systems. And I mentioned before that I'm on the .NET Experience team, so introducing a new command that uses CF, we didn't think would be the best user flow, so we let them use NetUse. And it also has better security, limiting one share per user. A security note about that, you're probably familiar with SSHing into your container, and it's great. You can go in as the VCAP user, you can check out what you need to check out, but I should mention that you cannot view the mounted drive using that same format. It's because the VCAP user is using a different security context, so it's just going to be blocked, and that's a good thing. The Windows workflow. So there are a few ways to mount your SMB share from your .NET app. The recommended way would be by leveraging Steeltoe. If you're not familiar with Steeltoe, it's an open source library built specifically for .NET Core and .NET Framework microservices. And if you're already using it, you know it's great. You can use it for config server, for circuit breakers, and you can install it via a NuGet package. But Steeltoe does require additional app code. For your storage account credentials, I definitely recommend CredHub. It's great for centralized credential management in Cloud Foundry. So for today, or for your first time setting up your SMB, we're going to use a very simple batch file approach. So we would add a single flat file with one line of deployment code, call it profile.bat, and we'll be using the cf setenv command to set our environment variables. And I'll show you a quick demo of how to do that today. Cool. So for this demo, I'm using Azure. So I'm in the Azure portal. This is where I'm keeping my storage account and my SMB share. My share is called demo share, and it's empty right now. And I'm going to grab the netuse command from the connect link and copy that and jump into Visual Studio. So here I have a .NET Framework MVC app. And I just added one function so that when I hit the final URL, it will plop a file right in my SMB share. And I'm adding the single file that I mentioned before, a batch file, .profile.batch. And pasting in the one netuse command, and I'm going to use environment variables for my SMB path and credentials. In PowerShell, I'm already logged into Cloud Foundry, and I'm going to push my app with the no start command. And since it's a .NET Framework app, I'm going to use the HWC build pack. Cool. And it pushed up without running, which is what I wanted it to do. So now I'm going to set my environment variables. So I'm setting the SMB path and SMB username and password. Great. Now that the environment variables are set up, I'm going to run the app. I'm going to grab the URL, and I mentioned before, this moment I hit that URL, it's going to put a file right in my file share. It's empty right now. I'm going to go to the index route. Great, hit successfully, and refresh my storage, and there it is. So that is the quick and dirty way of setting up your SMB storage, and I'm going to hand it over to Julian to show a more secure way of doing that.
So I promised that we were going to bring this home to make it work like Linux. So what if you were really hoping for something like that Linux workflow where you wanted to put your credentials into a service instance, you want to bind it to your app, and we had somebody ask us for this, which was part of what put the seed for this talk into my head. So the first thing we'll look at is create user-provided service workflow. So using CF cups to essentially encode all of those environment variables, and then using a simple script to peel them back out and perform the mount. In this approach, we're essentially allowing you to leave your app binary as it was. You just drop a little bit of PowerShell script into your app, and it handles the consumption of the user-provided service for you, does the mount, and then puts the location of the mount back into VCAP services so that your app can find it in the same way that it would in the Linux flow. So you see that top bit is basically just using JQ to parse the jQuery. And we had to do this in PowerShell, not BAT, because Windows batch files basically choke on environment variables that are more than one line. So PowerShell handles them, and VCAP services is, if you've ever looked at it, it's quite sprawling. So you can see there it is as it is. So we're just doing the new SMB mapping. That's essentially net use in PowerShell parlance. So what does this look like in practice? So essentially, we've already got the app pushed in this case. We've got a Pora Windows, which is that same app as we saw before, but pushed with a manifest that specifies, the Windows build pack and rootfs. And you can see when we curled it, it failed because it didn't have storage associated with it. So we're going to call cfcups with a share, a user, and a password. These are for a test server that's co-deployed. And then we're going to bind that to our app. When we restart, once again, it'll restart with the new environment. Come up, and it should have a file store, and then that same right endpoint should succeed. So here we're just curling the right endpoint, and hey, it works. So cool. Okay, so this worked, right? But it actually isn't very secure. Assuming that you care at all about the credentials that you've put into cfcups, just running cfenv on someone else's app will tell you the credentials that they've bound to their app, which isn't very nice. So if we want to make it secure, then we need to use the secure credentials broker. And this effectively uses CredHub on the back end to securely store stuff, similar to what we do in our Linux volume services. So if there's secrets, they get stored securely in CredHub, and then they get resolved at the last moment by the Cloud Foundry app lifecycle. It essentially takes this reference to CredHub out of the environment and uses embedded credentials in the app to go resolve it before your app starts. So there's slightly more script here. This is the version of the script that can pull credentials out of cfcups, the secure credentials broker, or if you're in Pivotal proprietary land, the CredHub broker, which is basically the proprietary version. And it's got a little bit more failure handling. So for the case where you want to run your app and you don't have a volume service at all, it'll skip the mounting step. So if we run through that flow, if we look at the marketplace for this CF deployment, you can see we already have a secure credentials broker installed and made available in this space. So we can create a new service instance, and instead of cfcups, we're going to create a service, which means we have to just fiddle this a little bit. This is our same command from before with that's creating a service instance instead of a user-provided service. And we're going to call it secure service or something. And then create service takes a -c instead of a -p for your metadata. And off we go. So we've got a new service instance. And we unbind the old one because we don't want it anymore. And bind our new service instance instead. And then restart once again. And you should see we get the same exact behavior we got before. Which probably makes this kind of an unexciting demo. here again, curling the right endpoint, and we get back our same message. So, very good. So this is effectively a couple of different ways. That script that we've added is fairly app agnostic. Gives us a way of, it's not quite the same as the Linux workflow because you do have to inject this little script into your app and also a JQ executable because that it seemed to be available in the standard Windows build pack. But it gives you a short path to just drop a script in, maybe edit it slightly, and then your app can consume volumes in much the same way you would with Linux, and also securely. So if you're interested in trying this out, there's some references here. The Secure Credentials Broker is, of course, just available on GitHub. It's an open source project. There's a PowerShell example and Steeltoe example for the approach that Daniella was talking about, and some documentation. I don't believe I've added a link to the script that we had up on the screen, but these slides are up to date, so you can crib it out of there, and also I will update the slide deck with the GitHub repo that has that for a Windows example in it. So, yes, we'll update the slide deck shortly. So, thank you all for attending, and if there's any questions, I believe we have plenty of time before the beer starts.
Yeah, so the question is, are there plans to further integrate this, maybe in the build pack or something?
There certainly could be. It's something that doesn't differ hugely in kind from like the app lifecycle stuff that resolves hub credentials. So, we didn't hear a lot of signal from customers that that was important to them. So, I think where we are is we're kind of resting on this, and we'll see what people say.
With multi-build pack, it's actually it's a small thing to put in a build pack, right?
Sure, right. But then it becomes a question of like, well, sure, it's a small thing to add a build pack. It's also a small thing to drop a script in. Like, if we wanted to really make it right, we ought to detect that it's required, right? Detect the existence of a volume mount, and then do it automatically so the user doesn't have to concern themselves with it. Provide a service broker that does it. So we thought about that, and we started thinking about like, well, do we want to go put plumbing in? And we spent some time investigating what that would mean. And we thought, well, while we're at it, we probably ought to take a look at how NFS ought to work, because we didn't want to like go down the path of a strictly SMB plumbing. And then burnt a little time on that and kind of came to the conclusion that that was more investigation than we wanted to do just then. So, so yeah, so this is kind of where we are. But definitely, if you feel friction around this or feel pain around this, let us know, and we can think about prioritizing it. All right.
Thank you very much.
Thanks, everyone.